So every year, do you get to accept it at like a ceremony and stand on stage?
Yep, I
That's
sure
gotta
do.
feel pretty cool.
Yeah, it does.
Yeah,
And we talk about it at our scholarship awards here at the college.
yeah. No one has ever handed me a check like this that I got to stand and take a picture with.
You
So
get one every year.
this is a great honor. Hey everyone, we're here at Ridgewater College on the Hutchinson campus looking at our machine tool program. I'm here with Greg, one of our amazing faculty, who's going to teach us a bit about the program. How you doing, Greg?
Just fine, thank you, Max.
Awesome. Would you start just by telling me and everyone that's watching a little bit about your background, professional experience, and in the program as well?
Yeah, so I got into machining specifically in 2000 up northern Minnesota, north central anyhow, up in the lakes area they call it, right?
Beautiful.
And so I changed a long-standing career to machining, and I got a little bit of training and went into work in the industry where I ran some big CNC machines. And as I got into as my career started going, I started moving south, mainly to follow and chase after better jobs, to go up the ladder, make more money. And it wound up bringing me to Hutchinson sometime in 2007.
Yeah.
So there's 7 years in industry. While I was working in Hutchinson in industry, again, I was trying to change jobs to move up the ladder and earn more money. I mean, that was my goal. And in doing so, I was caught up in a layoff at a company that I worked for in 2009, one of the third layoffs of the year. And so then I was faced with going back to get a job after a short unemployment trip. And in doing that, I found that the kinds of jobs I was seeking, the kinds of pay, people were telling me it required education. If I had some education to go with my years of experience, I would have opportunities for the kinds of jobs I was seeking. And so that led me to Ridgewater College. I came here, looked at the programs, knew I wanted to do machining, and so I pestered the instructor here until I could figure out everything I had to do to get in. The college, people in admissions and everything made it so easy for me by knowing just what to fill out so that I would receive scholarships, grants, and loans. And I came to school full-time while working full-time, and that was around 2010 to 12. And while I was going to school here, my drafting instructor used to tell me, your instructor is going to retire and you should apply for a job because you'd be really good at it. She's the reason I'm here today, all these years later. And so after graduating, I knew I wanted to apply to work here and be an instructor in the machine tool program. My instructor worked another couple of years after I graduated. I called him. I said, Dale, yeah. I said, do you know how you used a substitute when you couldn't be at the shop? And he's like, yeah. And I said, I'd love it if you'd use me, if you'd consider that. And he's like, oh, okay, that's good to know. Click. The next week he calls me, Greg, yeah, Dale. Yeah, remember what you said last week? Yep, be here at 7 a.m. tomorrow morning. Click. So I had to tell my employer I wasn't coming into work tomorrow and I was going to go to the college and start seeing what it was like to teach. And I came in that morning and students came in and got their toolboxes and rolled them to the machines and started doing what I had just got done doing. And pretty soon they had questions and they knew I was the substitute and they come over and asked their questions, and it just came out and the light came on in them and I was hooked on teaching. And I'm still that way today. So
yeah,
even more.
Yeah, well, that's awesome. What a great story.
12 years later.
Yeah.
So starting my 12th year teaching this fall. So
excellent. And how long has the program been at Ridgewater?
So we have a really well-established program that came from Wilmer some 20 plus years ago.
Okay.
It started on the East Campus, which was a much smaller area. We have a really large shop here. It's full of machinery and equipment, and it's 20 plus year with a good reputation and a well-established shop that I was able to inherit and take over being the instructor in.
Awesome. At a high level, for those that may not know, how would you describe what machine tool is?
Yeah, so it's basically cutting into metal, plastics, sometimes glass or and steels, of course, different types of metals, on a lathe, which does cylindrical work, or on a mill, which does more rectangular work. And if you can liken it to woodworking, anything you can do with wood, you can do with metal and whatnot in a machine shop. But it takes knowledge of the machines, safety. Safety is key. There's a lot of dangers in around this equipment, but when you learn to respect it and what the dangers are and how to work around it safely, students handle super sharp tools that would otherwise cut you if you just bumped them, but yet you can grab them with your hand and measure them and hold them and check them out and see if they're sharp, and so it takes that, with that knowledge, you can work around this machinery very safely, and you learn to do good, strong, rigid setups with sharp tooling in a lathe or a mill, and basically program or use the machine tool to shape the metal in whatever you want. So rigid holding, sharp tooling, understanding of how the processes and how they work makes machining a pretty easy and fun and exciting thing to do. So,
and then, there's the two maybe end applications that I think of are, one, you maybe be tooling something that will go into something else, a part like that, and the other might be more of a custom thing, like a custom project that you tool something.
Yep, all the time. So you're either making a single component for something or a part of an assembly where you have several components or even just a few that go together. A lot of times people will have things that are made that are broken, and they have to be maybe reverse engineered or to make different or better or stronger or just fix them.
Yeah.
It could involve welding to fix something up, and then machining to machine off that weld and put in a feature of a tapped hole or something that was there, a counterbore hole or something. So the industry for machining and manufacturing is so vast. It ranges from anything you can come up with at the letter A, almost all the way to the letter Z. I mean, we've toured companies around our area that made parts for the Mars rover. They're renowned worldwide medical industry in the metro area that does implants, surgical implant. Those are things that they machine and things like that. So very fascinating.
Yeah, it is.
And very vast.
Yeah. And this program it's only on the Hutchinson campus, correct?
Yeah.
So you get to come to beautiful Hutchinson if you want to be part of this program.
That's right.
Yep. Awesome. Well, I'm excited. You're going to show us some stuff today, some demonstrations and different things.
You bet.
All right, let's get after it. All right, Craig, this is the first place you wanted to bring us. What are we looking at here?
So this is like a 36-inch Kennedy roll cabinet. We refer to it as a roll cab. It's kind of the base and basis for a machinist toolbox.
Okay.
All the place where they would keep tools specific to machining.
Yeah.
Including regular shop hand tools. But on top of it, you can add, as you'll see through the shop sometimes, a riser or another small toolbox to get it up into the air and hold even more tools.
Yeah.
But so this toolbox is resemblance of what everybody in the program is getting through the Gene Haas Foundation Scholarship right now. A Kennedy toolbox full of tools valued around $2,500.
So everyone that comes for fall enrollment gets one of these tool chests full of the tools that they would need.
Yep, a brand new one, basically.
Awesome.
And so they'd get to use that toolbox and add to it while they're here in the program. And upon graduating, they would take complete ownership of it and leave with it. So pretty good takeaway from the program for that.
And that's because of a scholarship?
Because of the Gene Haas Foundation Scholarship.
Okay,
you bet.
Awesome.
And we have put together a special application for everybody in the program. So if you don't register for classes until just the month of August even, we have the application available to you.
Yeah.
And everybody's getting one. It's just for being in the program. So.
Oh, that's awesome.
Yeah, it sure is.
Huge advantage.
So this would have tools in it, like I said, that are specific to what a machinist would use, including regular hand tools. And of course, you see how things are organized in a drawer. A lot of times before students get their toolboxes or by the time they get them, they've seen me using this one in the instruction and demonstrations, and they've got an idea what they want to do with their toolbox right away.
Yep.
There's some specific tools that, again, are just basically for machinists. That includes a drill index and a set of precision parallels for milling on the milling machines.
Yeah. And up top, we have some pretty important things. What are these here?
Yeah, so this is an example of one of the first projects students do on the mill. And these are one of the tools that they receive. This in itself is a digital caliper that measures to very, very small measurements, like 1/1000th of an inch. So take an inch, break it into 1,000 pieces, and this can measure a couple of them for you. Basically, it's a quick and dirty reference tool where students can measure what they're making so they know when to stop removing material according to the blueprint or drawing.
Yep.
So this is called a caliper. It's just a digital caliper. And next to that on the toolbox is a micrometer. It's just a mechanical micrometer, which is good for measuring cylindrical work or work on the lathe versus a mill.
Yeah.
So pretty valuable tools. Most machinists do have these tools and bring them into the place of work and maybe get them calibrated at work and keep using them.
Yeah. And well, the awesome thing is with everyone getting one of these, I think you said earlier, it really just puts everyone on the same level playing field then. You start out with a huge advantage of having all these tools at your disposal rather than having to go out and buy them yourself.
Yep, or wait and see if nobody's using the one set that we have here, or sharing them with everybody, or just not having them.
Yeah,
really puts you at a disadvantage to the learning because you're not using the tools and doing the things others are doing at the same pace.
Yeah,
when they can just get in their own toolbox and do the work. So
awesome,
very valuable asset.
I think next you're going to show us a little bit on the CNC machines.
For sure.
All right, let's do it.
Well, I was going to just show you that. This machine, this Haas machine in this case or cabinet, transitions pretty nice from the manual lathes over there, except for the hand wheels. This is a more advanced machine. They have one with the hand wheels on it that are like the manual over there. So it was really a good transition. But still, students find that coming over to a smaller lathe like this and introducing the CNC controller is really interesting in their second semester.
Yeah.
To say the least, this is where everybody's going to or wants to get to. This is what industry is using.
Okay.
This TL1 just stands for tool room lathe, and this was their first one that they made with the cabinet type, and Callan is using one to do some of his final assignments for this semester.
Yeah. Awesome. So a lot of what you learn on the first year side, there's a little bit of, I think the phrase you used was geometric calculations, things that you have to know how to do, and then you bring it over here. It's getting a little bit more, technological, but you have to have that foundation and to be able to apply it to the kind of this new age.
So in their second semester, they start to learn to write and read NC code.
Okay.
And that's what makes the machine run.
Yep.
They also get an introduction to Mastercam software, where we actually model in 3D. We first 2D draw and then extrude into 3D models the parts that they're making, and then they can apply tools and tool planes. And that's what actually generates the code or makes the code for a lot of their more advanced projects. But in their second semester, they're basically learning to write and read this code.
Yeah.
And they have to read every code before they push the green button.
Sure.
And as they do that through their first few assignments, they start to really learn it.
Yeah. Yep. Are students generally pretty excited to get over on this side, or is this more intimidating to them?
So that can go both ways. We have such a vast array of students, from traditional to non-traditional, some that know what's in a toolbox or what a wrench is, and some that don't have a clue. And so even in every semester, in every year that I've taught a new group, we have all kinds.
Yeah.
We have some that are just excited to get here, know exactly where they're going and what they want to do. and we have others that come over here and reluctantly get started and need to be provoked and encouraged and helped. And once they get through those first few assignments, though, it just starts to feel more and more natural. And the more you do something, the better you get at it.
Yeah. Well, what a great opportunity to work with something so complex and advanced, but in an environment where you're learning and you can make mistakes and you're trying to figure it out. I mean, this is not a cheap machine, obviously. So
No,
what a
it's
great
not.
opportunity for the program to have it.
That's right.
Yeah. And how many do we have of these?
So we have 5 lathes in our shop. They start with these 2 TL1s, and then we go to an ST10, which is a turret lathe or a slant bed lathe.
Okay.
And then we have 2 lathes with live tooling in them, which is very big in industry.
Oh, okay.
So they have mill tools in a lathe tool, so you have 2 machines in one.
Yeah.
Taking away the need for going from one machine to another, providing opportunity for air, right?
Yeah.
So that's what industry is driven to, and that's what we pride ourselves in having in our shop, is that lathe with live tooling. So very, very nice tooling. Students, once they start on these, pretty soon there'll be like so many students in the shop that these will be tied up, and then they learn they can get on that one, and pretty soon they're using those machines and they don't even come back over here.
Yeah.
Because they're pretty basic compared to those.
Awesome.
Make sense?
Yep.
So 5 lathes, and then we have a mill shop over here on the south wall, and we should go over there and
Take a look at it? All right, let's do that. What are we looking at here?
So we're looking at a machine that's a little dirty with tooling in it. This is that turret or slant bed lathe that I was referring to.
Okay, yep.
It has turning tools in it plus milling tools. It has an end mill in here that will come in, and so this did some turn work, boring, and then an end mill came in and machined these slots in. And otherwise, without that, you'd have to take this out of your turning machine and go to an end mill and set it up in a 4th axis chuck or something and put those slots in it. So now we have a machine that is all inclusive there with a lathe and a mill.
Yeah. So give me a hypothetical. When might you make a piece like that? What might be the instance?
So in industry, companies will get requests from other companies that have a need for something.
Okay.
And whether or not they're already drawing their own blueprints or modeling something, they come to a company and present to them their need. And most machining, manufacturing, and job shops will step right up and help them figure out what it is they need, take from them what they have, and then turn it into something they can use in their shop. Work with them as a customer then, and give them something to see, will this work, or does it need adjustment? And then when they get the go-ahead to make them, they'll make anywhere from, here we have 3 to maybe 3 million parts before they're done with a job or a contract or something like that.
And it might be maybe a small piece that goes in a tractor or a pressure washer or a car.
Yeah, of course, or food processing equipment.
Okay.
It's really big around our region.
Yep.
So,
Awesome. And is this the machine that would make just when you're trying to perfect the first 3 or the 3 million?
This would do both.
Both. Okay. Yep.
If I wanted to, I would need to have a machine that has both tooling in it, both mill and lathe tooling in it. So I would want to use this machine to produce and proof out what our abilities would be, capabilities, and then use that through production too.
Awesome.
This is definitely a high-end industry production machine.
Yeah.
Again, a nice Haas.
Yeah.
Piece of Haas machine.
Great. You can come in here and learn and mess around and.
Yeah. And once students are doing a lot of this and they're getting their assignments done, those that are capable or have a need, I've had students come in and say, hey, we need to make this for our tractor at home, and here they are doing that in their extra time if they have some that left during the week. So and we allow that. So this kind of ends our lathe shop. It wraps around the corner here. And then down here we have 6 mills. 6 Haas mills.
Yeah.
And our biggest one is down at the end turned on, and I wanted to maybe bring you down there.
Yeah, let's go take a look at it.
Showcase that.
That sounds perfect.
So we were looking at the lathes.
Yep.
And in the mills, this is kind of the top machine in the mills. It not only has the traditional 3 axes, X, Y, and Z, but it introduces the A and the C also. And so it's referred to as 5-axis machining.
Okay.
So we can work on multi-axis axes. We can do contour machining.
Okay.
And what I wanted to do, I didn't have this set up yet, but I was just going to introduce the tool here so that you could see it. I don't have it set up, or I'm not going to run it, but
Yeah, no, that's all right.
I have a company that just donated this blue tooling to us. Boy, several $1,000s worth.
Yeah.
And this particular part needs me to put a couple holes in it to mount it into this machine.
Okay.
But here's how it would look and sit in the machine if students got over here to use this. Now, this can be used like a traditional 3-axis machine. It doesn't know. If you give it 3-axis code, that's all it's going to do.
Yeah.
But this can also do the other 2 axes, which produces the 5-axis or contour machining, which students learn in their second year on Master Camp.
Okay.
It's the advanced machining. And just like the lathe with live tooling, the 5-axis machine is what they have to do their final projects on. And final projects, as we may have mentioned earlier, is when they have an assembly of something. They've got to make a few parts that go together and fit.
Yep.
And everybody's making amazing things. We have a student making a cribbage board.
All right.
That hinges with pockets to hold all the pins and cards, and he's machining all the pins and everything. And we have a student that's going to machine a pump for a water pump for a steam engine.
Okay.
So he's got a broken pump, and he's going to reverse engineer it and make a brand new pump with its components, inside internal components that make it work.
Yeah.
And that's what our students do as their final projects in their second year. So
yeah.
Pretty advanced machining using advanced tooling.
Incredible.
Yeah. As we looked at some small code that was written by hand, we can look at some larger code here. And I don't know, you can just see that this has thousands of lines of code that will run here.
Okay.
And it'll graph out over here. It's drawing it over here as it's running over here. And there's just thousands of lines of code there that once students understand how just the basic one tool of code works, then all we're doing is we're adding more tools, and the code all generally works the same to begin to bring your tools safely to your work. Mm-hmm. And then it just does a lot of different work in the meantime throughout the part. And then it always comes to a point where it exits safely from your work. So once they start to understand that, they safely bring every tool into the work and then let it do its work and then safely take it out away from their work. And then the machine will stop and pause while you gather your things together, maybe do some inspections, and then push the button and make it go on to the next tool. So a lot of times that pause might entail opening the door and going in with your caliper or micrometer and pulling some measurements in case you have to make some adjustments. High-end machine here.
Yeah, seems like it.
High-end, high dollar.
Yep.
A small one. They get so big they take up the space of 2 or 3 or 4 of these all in one. So.
But again, a great opportunity to have access to something like this when you're learning.
Yeah, and we really think that's a benefit to Ridgewater College and the machine tool program here, having the longevity and the reputation that we have, and the ability from the Gene Haas Foundation and our great college putting an investment into the tooling in the space here for students to learn. Really is what we want to showcase. So.
Yep, absolutely. All right, well, now we're in a space that looks a lot different than a machine shop, a little bit more like a classroom.
That's right. We are in our classroom right across the hall from the machine shop.
Okay, yep.
So it's in a roundabout with our 3D printers outside. We have 12 seats of computer software, including Mastercam and SolidWorks. And using SolidWorks, we have this 3D handheld scanner for our reverse engineering course.
Okay.
Students can take the computer and a handheld scanner.
Yep.
And when they turn the button on, this turntable will spin and they will start to scan an image into the computer software. And after an example here, they have an image probably from here. You would maybe turn it on its side or something, or turn it over, and you would have multiple scans, and then you could clean them up and mesh them together into a nice solid model that can be taken into the SolidWorks or into the SolidWorks software from the specific scanning software. And then you can apply planes to your model and start to extrude features or trace them or something. It's a method of reverse engineering.
Okay. Yep. So if you had a piece, you wanted to have more of that piece, but you didn't have the file from when you actually had made it, basically?
Sure.
Yep.
And if I had something like this, maybe with a caliper, I could sit down and draw something up relatively quick.
Okay.
But if I had something like this mouse with all its contours, shapes, and all the different textures in there and these features, I could literally scan that in about 15 minutes worth of work, where otherwise it may take me days to sit and model all that and figure it out.
Yep.
So that's the real advantage to handheld or 3D scanning, is where you have something that's otherwise almost impossible to do. And now, boom, a few scans, clean it up, mesh it, merge it together, take it into SolidWorks, and off you go with it.
Awesome.
Half a day's work at best.
Yeah. Yep. Yeah, that's awesome.
Okay.
And you said there might be some changes to this classroom if students come in the fall.
That's right. So our classroom has been this way for a while. We have new college look and colors coming in. And we have kind of a weird setup in here that just dawned on me one day. The students are sitting different directions, and we have kind of a little older technology or whatnot. So what we're looking at is maybe moving the instructor position over on this wall with two big giant monitors for teaching the softwares and coursework, and then we'll rearrange all the seats so they're all looking one direction. Get some fresh college color paints in here and LED lighting probably, and we'll have a new look here going into one of the semesters coming up soon. So
that'll be great. All right, we're here with Jaden, who's in his second semester in the machine tool program. How you doing, Jaden?
I'm doing amazing today.
Awesome. So I want to ask you a few questions about the program, if that's okay.
Mm-hmm.
What would you say is your favorite thing that you've learned so far in the program?
My favorite thing would be engraving on here, and then knurling, and a couple other new things I've learned on the lathe. It's just kind of varies with the area with it. Yep.
Were they challenging to learn? Or took a little bit?
All of it was kind of a wrap around from what I knew before, and learning now. It's a big step. Mm-hmm. Different changes and all that.
Yeah. What would you say is the hardest thing that you've learned so far in the program?
Hardest thing would be the robo, or I forget what the arm is called. What's the arm? The PC Demus? Yep, the roamer arm. That one was a big step because it's so many little things, and then it's like, well, what did I do wrong? Well, it's just the little dumb thing you did.
Sure.
It's a big step.
Attention to detail.
No, yeah.
Yep. Absolutely. And how would you describe the faculty in the program?
They're awesome. Everyone that I've ever asked for help, everyone's helped changing my outlook on it and challenging me to think differently on the thing that I've got troubles with.
Yeah.
Yeah,
absolutely. And then the last question, anyone that is maybe going to watch this that's kind of considering, I'm kind of interested, I'm just not sure about machine tool, what encouragement would you give them?
Ask any question you have. Nothing is a dumb question. I mean, everyone has their different level of knowledge on the thing. Mm-hmm. That's what everyone's here for. If you break something, that's what the whole thing is for, So don't be scared. There's a lot of anxiety, but that's how you learn, So.
Yep. Awesome. Well, thank you very much, Jaden. I appreciate your time. Have a good rest of your day.
Yep, you as well.
All right, Craig. Well, we just covered a lot of ground. That was super interesting. Let's talk a little bit about some of the industry partnerships that we have in the program. I was holding a large check earlier. That's a pretty good relationship that we have.
Yeah, it sure is. So the check you were holding, Max, was from the Gene Haas Foundation. For decades now, they have been committed to making financial scholarships available to students in education. And we've been a recipient of it for 10 years about, and it's gone up. It's provided an amount of money that we have to offer students those toolbox scholarships.
Yeah.
And up to $2,500 scholarships per semester right now. Telling students about it, the application period for fall being deadline June 1.
Yep.
If students know they want to be in this program, it'd be good to enroll, get your orientation done, and or register, get your orientation done, enroll for courses, and that application is made available to you, where you can not only tap into the Gene Haas Scholarship, which we'll make available to you right up until August when school starts, but you also, with one application, are tapping into several industry partner scholarships to start your first semester with, if you choose. So,
so how much of tuition could be covered then?
Yeah, so the cost of the program being around $14,500 for a 2-year degree or diploma. $2,500 scholarships times 4, there's $10,000. The opportunity to tap into other $500 to $1,500 or $2,000 scholarships could add up and take care of some more of that. There's other grants. There's some scholarships or some funds that come from the government that can also take up some of that cost. We're looking for our first group of graduating students to maybe tell us one day they have a money surplus rather than I only needed X amount of dollars. That's what it cost me out of pocket for my degree. So we're getting pretty close to seeing someone have their full tuition paid for, plus leave with the toolbox full of tools.
Yeah, that's awesome. It's an incredible opportunity.
Yeah, it is.
So when people are, you said it was a 2-year program. When people are graduating from the program, where are they typically ending up to first?
So we have a lot of machining and manufacturing industry right around Hutchinson. A lot of students are working in industry while they're going to school. These companies work well with us to maybe sharpen our tools for free, and that helps us with our budget. They offer internships as they're looking for students to fill jobs in their company. They'll be very flexible with them to let them go to school during the days, work for them over the summer, and maybe work nights or partial week during the school year. So it's very flexible for them in that way. And they get to work with these local companies. And we tour companies up to about a 50-mile radius. So we get into the West Metro and out into the country out west, a little farther toward Wilmer, our main campus. And students find companies that they decide, or they get, it piques their interest in where they could work as we're touring those companies. And they go seek them out and find employment there.
So job placement and maybe starting wages that we're seeing?
So job placement is very well. We put out a survey to our graduates. And of those graduates that respond, 100% of them have been working in the industry, and that statistic is on our website. I've surveyed students while they're interning, and they have told me what I've heard just on a tour the other day from a company that while they're going to school, mid-20s for starting, and upon graduating or having a diploma or a degree, bumping up into that $30+ an hour range. So
great place to start.
It sure is for a beginning.
So talk me through a little bit, what does a typical week look like in the program for a student?
So right now, post-pandemic, we have been on a 3-day school week. It started with some things that we had going on and just seemed to keep working that way to our benefit. And one thing we found is that based on the curriculum level and the time that students are in the shop and the amount of coursework which is online, something we call Desire to Learn, or D2L. It's a web-based platform of the program where students can get all their announcement, current events, they can find all their assignments, print their documents, take their quizzes, pretty much do most of their schoolwork to even see their grade. And they're just completely involved in that from Friday, typically when a new assignment, a new biweekly assignment goes out. So Friday, Saturday, Sunday, Monday, there's 4 days of just going through the coursework in up to 1, 2, 3, or 4 courses, whatever they'd be taking per semester. And then when they come in on Tuesday, we're in the shop for up to a few hours doing Q&A. We come out in the shop and I actually do demonstrations that help them. I basically spend time connecting with them to make sure they have what they need to come into the shop and make the projects. As you know, a technical trade program where you make stuff really involves a lot of making stuff. So we try to provide as much of a 3-day school week of shop time for them as we can. And they, with bi-weekly assignments, 2 weeks, 6 days, they pretty much complete, start to finish, a project in 1, 2, sometimes up to 3 courses simultaneously. And then it all starts again with advanced or, progressive assignments and projects where they learn more or newer methods, processes, and toolings as they progress through the program.
Yeah. And if you were to kind of project ahead, where do you see demand going or changing in the industry here?
Well, I suppose with the implement of AI and industry always seems to be a little ahead of education with what they have. In fact, some of the machinery I've showed you, we've been fortunate enough to secure and get in our program. A lot of schools may not have that access to that or something, but as we do have it, I feel like we're keeping up with industry and where they're going and what they're offering. I suppose if I could say anything about that too, we just got back from an all-day tour where we went up to the West Metro area and toured 3 major machining and manufacturing companies. And interesting enough to say that our students were so engaged with them inquisitively about everything they were seeing and hearing, but yet on the other side, from them companies telling us how great they felt our students were, really makes me feel good about where we are going and where industry is going in the future. We at school can get students safely understanding the use of this machine and a lot of modern technology, but it's industry that's going to take them to places and heights we never could.
Sure.
As they take them, as students find their way now after graduating, being employees, maybe family people or whatever, people of the community that make a community work, they find what they want to do, whether it's making tiny parts and 800 per shift or working on a 10-ton weldment all week long on a machine that you ride. Yeah. So it's a very vast and open opportunity for those things to do. Yeah.
All right, last question. If I'm a prospective student watching this, as you once were, where do I start? If I think machine tool is something I'd love to learn more about, where should I go first?
Yeah, good. So contact college admissions. Check us out on our webpage, the Machine Tool program. Every program in the college has a webpage, and you can click on that link, learn more about your instructors, watch some videos about our program. And of course, as often as we're open here, we have an open policy. People can walk in, potential students, make an appointment with me, or make an appointment with admissions. They will set up a scheduled time.
Yeah.
But oftentimes when I'm not in class, I'm in the shop, I'm open to people just walking in and saying, hey, we decided we'd get over here and look at the machine tool program. And more often than not, I can find 10, 15 minutes to make and spend with someone to give them all I can in that time about the exciting and interesting career in machining and manufacturing.
Yep. Well, there you have it, everyone. That's the machine tool program here on the Hutchinson campus at Ridgewater College. If you want to learn more, if you're interested in hearing more about machine tool, if it's the right program for you, you can reach out on the website. You can call the recruiting office, set up an appointment, come down here, visit with Greg. That's it for today. We'll see you next time.